For the last video of section 4.4, we want to discuss Simpsons Paradox. Simpsons Paradox is a really useful thing to know about because it allows you the tools to better analyze two-way tables, which are often given to you in media, and you really need to look at them with a critical eye, and this little example here is going to show you why. So we have the local newspaper examined the town's two hospitals and found that over the last 6 months at Mercy Hospital, 79% of patients survived, while at County Hospital, 90% survived. The table below summarizes the findings. All right, so we're going to compute the marginal frequency distribution, which means we're going to find these marginal frequencies over here. And this is a really, really common technique. Rather than using the percentages, what we do is we make it out of 1,000. So we say, okay, 79% out of 1,000 would be 790 survive and 210 die. So when you're faced with percentages and you want to have a better understanding of them, sometimes it really helps to be able to make a table like this and kind of make it so that it adds up to 1,000 for each particular row. This, by the way, this column right here adds up to 1690, right? Okay, so 1690, and that would make 2,000 over here for the total, the grand total, if you will, the total of the totals. All right, so we found the marginal frequencies because we just found the whole numbers there. Now we're going to compute the conditional distribution of mortality by hospital. See the by hospital? So that means we're going to go along the hospital row. So you're going to take 790 and divide it by 1,000. Which would be 0.79, which makes sense. That's the way we set it up. And then the died here would be 210 out of 1,000, which would be 0.21. And then the grand total for that row would be 1,000 out of 1,000 because you have all 1,000 patients accounted for, which is 1. Then for County Hospital, you'll do the same thing. You'll say, okay, it was 900 survived in County Hospital, which gives you 0.90. And then 100 died, which gives you 0.1. And in the end, you have 1,000. All right, so now based off of that conditional distribution, which hospital would you prefer to go to? Well, I think it's kind of obvious, right? I mean, County Hospital, look at their survival rate. So you have a much greater chance of living, apparently, at County Hospital. There. County Hospital had a much greater chance of living, apparently, when you go there. So, because County Hospital's survival rate was 90%, and Mercy only had 79%. All right, now on closer investigation, it was observed that the patients were categorized upon admission at being in fair or better condition or poor or worse condition. So if you were in fair condition, that's one scenario. If you were in bad shape, that's poor. Okay, so when the survival rates were examined for these groups, the following table emerged. All right, so here we have the survival and the death right here. So when we add these up, we get 590 total. Okay, so we have 590. There we have it. And then while I'm on the subject, we have 890 here. Okay, so Mercy had 590 that were submitted in fair condition. County had 890 that were submitted in fair condition. So the patients that are in the better shape to begin with, Mercy only has 590 of them. Now, what percentage of them live? That would be 580 divided by 590. Let's go find what that is. There's the calculator. So if I take 580 and divide it by, oops, hold on, my calculator is being possessed there. 580 divided by 590, I get 0.983. So 0.983, which is about 98.3%. Okay, so now let's do it again for the County Hospital. So they have 860 living out of 890 that were admitted. So let me take that 860 divided by 890. That'd be 0.966. So interesting. The hospital we thought was better is actually doing a little bit worse with the patients that are in fair condition. Just a little bit. All right, now what about if you were in poor condition, if you're in bad shape, like a gunshot wound or on the verge of death, something like that. Well, there's 410 of them here at Mercy Hospital, and there's only 110 of them here at County Hospital, because I'm just adding those up. Okay, so now we want to be able to take the totals and find it. So we say the percentage that live was 210 divided by 410, which is 0.512. Now remember, these are patients that are in very bad shape to begin with, so they're poor condition or worse. All right, so that's 51.2% of them survive. And then here at County Hospital, 40 of their 110 patients, 40 out of 110. So that would be 0.364. Let's round that, 0.364. So that's 36.4%. So take a look at this real quick. Mercy is doing better with the fair condition patients. It doesn't get as many of them, but it does better with them. And Mercy is doing much better with the poor condition patients, but it has a lot of them. All right, so what's going on? Well, because Mercy gets so many poor condition patients, even though it does very well with them, its overall numbers are worse, right? So if you take 580 plus 210, you're going to have 790, this number right here, right? So if you add those two numbers up, that's what you get. But when you look at them in each in their own groups, they're actually doing better than County Hospital. Okay, I just typed it up. So Mercy gets almost 4 times as many people. And I'm getting that because if you look at the poor condition right here, Mercy has 410 to County's only 110. So that's almost 4 times as many people in poor condition or worse than County. So even though Mercy does a better job with those patients than County, they lower the overall survival rate of Mercy Hospital downwards because those patients were in such bad shape upon being admitted. And this is Simpsons Paradox. It's all well and good to kind of look at the aggregate numbers. That's what these are called, aggregate numbers, when you kind of lump them all together and say, oh, look, you want to go to County because County does better. However, when you break it down and actually start looking at the different groups of patients and you realize, oh, Mercy actually does better in both categories. The trouble is that Mercy's getting so many of these poor condition patients that it's pulling their overall numbers down. So which hospital will we choose? Hopefully you would choose Mercy Hospital. It does better with both groups of patients. There we go. It does better with both groups of patients than does County. And now we've learned what this little box is telling us here, that it's very important to look at numbers not just in aggregate, but to look at them when they're broken down in other ways so that you can discover if there are any lurking variables, such as poor condition was in this case, that might be affecting what's happening. Right? And that's what this little box is saying here. So two variables sometimes appear related in a certain way, but when you break down those variables on a third hidden variable and take that into account, then that apparent association disappears or even reverses direction, which is what happened here. So this behavior underscores the importance of design of a statistical experiment, right? So you want to be careful to account for that design, those poor condition patients or whatever when you're making up your study, but also that you expose those flaws as you release your findings. And you want to be very particularly careful about them when you try to make interpretations, because you might start thinking County's a better hospital and then you go to it and actually don't survive because it was actually not the better hospital of the two. All right, we're done with section 4.4. I'll see you back here for tests of independence and homogeneity.